Okay, Mary babysits for $4 an hour. She also tutors for $7 an hour. So those are the two things she does. She babysits and she tutors for $4 babysitting an hour, $7 tutoring an hour. She's allowed to work no more than 13 hours. Here's our keyword. Our keyword's no more than, and here's our total, 13 hours per week. She wants to make more than, more than $65. Write a system to model this situation. All right, so our totals, we already circled. Our totals went with our keywords, right? So our totals were 13 hours and $65, okay? But I need to put the inequality that's gonna go with those. So 13 hours, she works no more than 13 hours, which means 13 is our maximum, right? We wanna work less than or up to or equal to 13 hours. So we want the amount that we work, hours we spend working, which is gonna be over here, to be less than or equal to 13 hours, right? 13 is our max, that's why it gets the greater sign. It's our maximum, okay? And then she wants to work more than more than $65, which means the amount she's making, which is over here, needs to be greater than $65. It didn't say at least, meaning it could equal 65. It says more than 65, okay? So the amount of hours she works needs to be less than or equal to 13 hours, and the amount she earns needs to be greater than $65. So variables, we could either use B and T, or we could use X and Y, either one. We'll use B for hours babysitting, and then we'll use T for hours tutoring, okay? And then our inequalities. So what has to be no more than 13 hours? It is the amount of time she spends working, okay? So the amount of hours babysitting plus the amount of hours she spends tutoring needs to be less than or equal to 13 hours, okay? And what needs to be greater than 65? Well, that's the amount she's earning, okay? So since she gets $4 per hour she spends babysitting, and she gets $7 per hour she spends tutoring, that all needs to add up to be greater than $65. And that's it. Okay, so Carlos works at a movie theater selling tickets. The theater has, at most, we see a keyword already, at most 300 seats. And they charge $7.50 for adults and $5.50 for children. Okay, so those are the two things that make up our different seats, right? We have adult seats for $7.50, and then we have children seats for $5.50. And the theater expects to make at least, so there's a keyword, key phrase, at least $2,000 for each showing. Model the situation below, okay? So you see our totals go with our keywords always. So one of our totals will be the 300 seats that went with at most. So 300 seats, and that's at most, okay? So 300 is the greatest. It can be equal to or it can be less than. We looked at our cheat sheet, we see at most for less than or equal to. So the amount of seats that are gonna be sold has to be less than or equal to 300, okay? Our other total is $2,000, and that's at least, meaning they wanna make greater than or equal to $2,000, right? At least is greater than or equal to. So the amount of seats that they sell has to be less than or equal to 300. You can't sell more than 300 seats if you only have 300 seats, right? And then the amount that they make needs to be greater than or equal to $2,000, okay? Variables, let's use X and Y here. So we can let X be our adult tickets. So we'll say number of adult tickets, and we'll let Y be our number of children tickets. Okay, so tickets, or I guess seats, either one. All right, so we can only sell at most 300 seats, which means the amount of adult seats plus the amount of children seats needs to be less than or equal to 300 total seats. And $2,000, so we're gonna make $750 per adult ticket or adult seat, and we're gonna make $550 per children seat, and we want that to give us greater than or equal to $2,000. And that's it.